and good luck.
Thank you. Good evening or good morning or good afternoon, wherever you are. My name is Feline Hermans. I'm associate professor at Leiden University in the Netherlands. And today I want to share with you a programming language that I've designed called Hedy. But before we dive into the details of Hedy, I want to talk to you about why did I create this programming language? What is my history into programming? Because maybe you think that if I have created a programming language that's meant for programming education, that I know a lot about teaching. Well, I know a lot about teaching now, but when I started to think about Hedy, actually, I didn't know that much about programming. So let's go back to the year 2013. This is me here on the screen. And in the year 2013, I started to teach a group of children in Rotterdam, where I lived at the time, and I started to teach them programming. So this was a group of kids. I think the youngest was 8 and the oldest was maybe 13. And this group already existed and they used to have a programming teacher, but the programming teacher quit. So this group of kids was in need of a new programming teacher. And through networking, they came to me. So I thought, well, it's a group of kids and I can do programming. So how hard can it be to teach kids programming? So I was like, yeah, sure, children, I will teach you programming. But I didn't really know anything about teaching. At this point in time, I just got my PhD in software engineering. So I definitely knew programming, but I really didn't know anything about teaching. But again, I thought, they are small children. How hard can it be to teach them programming? And then what happened is I started to think back sort of subconsciously about my own history of learning to program. So how did I learn programming when I was a kid? Well, when I was 10, this is me as a 10-year-old, my dad had a computer with no internet, of course, because that's how old I am. Just this command prompt in DOS, even not even Windows, where you could type commands and you could type programs. And how did I learn programming? Well, there was no teacher that taught me programming. I sort of taught myself programming to a certain extent with books. So I had this book, Basic Computer Games. That sounded really interesting to me because, again, there was no internet, no Steam. I couldn't download any games. So I thought, with this book, I can create my own video games. That would be interesting. And this book wasn't necessarily a very pedagogically, didactically strong book, because if you would open this book, maybe you're familiar with this type of programming book for kids, this is what was inside. So it just printed out basic codes that I copied into the computer. And at this point, when I was 10, I didn't really know English very well, so the words didn't even have any meaning. So I just copied all the texts, and eventually I did figure out what it all meant, and I learned programming to myself to a certain extent. And this isn't just me that has this view on programming that you could just teach yourself programming. Many professional programmers that are my age, let's say the children from the 80s, sort of share this idea of, I taught it to myself, so kids that want to learn programming, if they're interested enough, they will also teach themselves programming. Unsurprisingly, if you're an educator, it didn't really work that way. So I also bought similar books for kids, and I thought, well, how hard can it be? I taught myself, so why don't you also read this book very carefully and teach yourself programming? It didn't work. And the interesting thing was that children were very vocal about how hard it was to learn. So I remember myself thinking, but I explained this to you 1 week ago. I know, how do you not remember this? But kids were like, I don't know what to do. This is really hard. And I also got sort of sad, right? And frustrated. I was like, why aren't kids learning? Why aren't they having fun? Why aren't they reading? Why do they need my help so much? Why is programming so hard? And this made me reflect on our community as programmers. Why is programming so hard? What is so hard about programming? What are the aspects that make programming so hard? And again, I didn't really know anything about teaching. I knew things about programming, but I didn't really know how to teach anything. So I had a really hard time understanding what aspects of programming made the kids struggle so much. Again, I was thinking, why is programming so hard? What elements of programming make it so difficult? And then if you start reflecting on our community, there are certain parts of programming that we collectively think are important and that we collectively think are not so important and not so hard. To give you an example, by and large, the programming community seems to agree that syntax doesn't matter. So the way we type programs, whether or not there's a round bracket or a curly bracket or rectangular brackets, how the program language exactly is written seems to not matter. And it's very easy to find all sorts of comments like this on the internet. It doesn't matter, syntax is not so important, because you can just Google. The most important part of programming is Googling, and you can just look up the syntax. You can just Google syntax. Here's another tweet that says programmers are just people with very good Googling skills. So it seems that our community emphasizes things like programming concepts, problem solving as important, but syntax, how you actually get something inside the computer, is generally not seen as so important. And this didn't correspond with what I was seeing in my programming club. I saw kids struggle with what bracket goes there. Oh, teacher, is it a colon or is it a semicolon? Or is it a period here or should a space go there? So what we as professional programmers see as not important was one of the obstacles for children. They were struggling with where does the space go or where does the bracket go? And that made me wonder, maybe, just maybe syntax matters more than I thought. Maybe syntax is more important for learners, for novice programmers, than we all of us programmers, agree on. Just to give you an example of how hard syntax is. Sorry if you're Greek, because this exercise is going to be a little bit less fun if you know and read Greek. But assuming that you don't know Greek, if I would ask you, what is your answer to this sentence? Like, you have no plan, right? You don't know the letters. What can you do? And of course, then I can say, oh, but this is not really hard. You can just Google all the words. But then that is not so easy, because this is a picture. You cannot even copy paste this into Google. So just typing this sentence is hard if you don't have a Greek keyboard layout set up, or you don't know how to get these characters. Just getting it into Google is already hard. And this was very similar to the things that children in my programming club were struggling with. Just knowing the right words to Google for was a struggle, and then interpreting the answer, because even if you would type this into Google, you would get a translation, but is that the right translation? Is that right for this context? So just being able to Google a sentence or syntax already requires a certain level of understanding. If you are trying to read this sentence, so imagine you're really trying to read the sentence. Imagine I will give you 25 euros if you can give me a correct answer response to this sentence. Then your brain has to work really hard, right? You have to go like chi, alpha, epsilon, rho, omega. And then once you're at the fifth letter, you start forgetting the first. Overwhelming and confusing. So what you're experiencing there, if you're really trying to puzzle a sentence together in an alphabet you don't know, in a language that you don't know, is called cognitive load. Your brain gets really, really full with all the letters, and you cannot hold all of them in your brain at the same time. And there you also see that prior knowledge is really important, because the Greek sentence is really hard, but the word cognitive load that's in the bottom of this slide, that's easy for you, because I assume you read English very well. So you can read sentences, but in the context of a language that you don't know, it gets really confusing. And we call this cognitive load. Your brain gets really full because it has to concentrate on too many details at the same time. So when I started to learn about cognitive load, and I realized that cognitive load is something that other people, not me, a programmer, but other people in other fields had really thought about in great detail. Other fields that we also teach, like language and math, they have their story straight. They know how to teach things. Like, for example, let's look at math. So if children learn simple calculations like this, like 3 plus 4, then they practice a lot of small steps. So it's 3 plus 4 and 3 plus 2 and 1 plus 4 and 4 plus 7. How often do you do this when you're a kid? Hundreds, maybe thousands of these small calculations. Why? Because this builds up in your mind a whole repository of quick answers. And then the next level, you can say, okay, now 414 plus 87, I can do this. Why can you reach this level? Because 4 plus 7 is the first step of this bigger calculation. That is already in your brain. 4 plus 7, you can just go, oh, 4 plus 7, 11. Imagine if you're still doing 4 plus 7, 1, 2, 3, 4, 1, 2. If you're just still counting like that, then it will be extremely hard to get to the level of these larger calculations. So you need to have practiced small calculations to get to the level of larger calculations. The same is true for language. So imagine when children are learning their first natural language. Imagine this is English. Then you also do this step by step. Initially, if kids learn their first natural language, they don't do everything right from the beginning, right? Firstly, we're happy if they can just do letters, if they're 5. And then if they're 6 or 7, then we start with sentences without capitals, without periods, without commas, just a sentence with words. We're like, nice going, well done, this is a sentence. And then gradually we add rules. And after a while we say, hey, from now on, sentences start with a capital letter. And the kid's like, okay, that makes sense. Practice, 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 practice. New rule. From now on, every sentence ends in a period. Kids are like, okay, fine by me. Practice, 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 practice. New rule. From now on, sentences can span multiple lines. That's the power that we unlock. If you split sentences with a period, then it doesn't need to end at the end of the line anymore. Then you can have sentences that are longer than a line. And if you're a 7-year-old, this is like, right? Wow, sentences can be so long. Then it can be like 10 words. So gradually you build up the rules that children have to play by, because every step in isolation first needs to be practiced. So then look at how programming education manages the cognitive load of learners. For example, here's a little bit of Python. This is Python that I would happily have taught in 2013 to, let's say, a 10-year-old, because this is actually quite easy Python. This just counts 1, 2, 3, 4. Well, in fact, if you're a programmer, this actually counts 0, 1, 2, 3, because we are horrible people. Anyway, conceptually, this is not a hard piece of code, right? Counting to 4 is something that you can expect a 10-year-old conceptually to easily do. So I didn't understand why this was so hard. Hey, child, 1, 2, 3, 4, just put this in Python. So the kid put this in Python, but actually it's so hard. Like, look at the individual things that you have to get right. 4, I, in, range, open bracket, 4, closing bracket, colon. Then you have to go to the next line, mandatory. 2 spaces. If you don't know Python, Python is so precise that you have to put spaces in the right place. The word print, another opening bracket, an I, a closing bracket. So this easily has 9 elements, maybe even more if you count precisely. And we know from cognitive science that your short-term memory, which is where you are doing your thinking, can maximally hold 9 elements. More than 9 is very, very unlikely. Maybe you've heard of this research called the magical number 7 plus or minus 2, which means that your working memory can just have between 5 and 9 elements. This is easily more than 9. This will for sure create a cognitive load in the brain of a child that is just way too high. This is too much. Their brain is just going to be overloaded by this. And that leads to frustration, because I think conceptually this is easy. So if I'm focusing on problem solving and on concepts, and if I'm in this vein of the programming community saying, oh, syntax doesn't matter, that I don't understand why this is so hard. And this is exactly the situation that I was in. I didn't understand why this was so hard. It seemed quite easy conceptually to me, yet children were struggling. So at this point, I started to think, this is what we do in programming. We give them everything at once. If you compare that to what we do in language education, that's like the final thing, the final language is what we give them with all the rules unlocked. Why does it have to be like that? Why can't we also have these initial steps like we do in natural language? Maybe before you do a for loop with everything, all the bells and whistles on, and maybe initially we can say, hey, that colon there isn't really needed. We can just have that. Initially, you don't have to use it. And maybe it can be even easier. Maybe before that, we can say, you don't need to go to a next line. You don't need to do the spaces in the beginning. You could just print everything on one line, just a little bit easier. And before that, we can say, it doesn't need to be for I in range, open bracket, for closing brackets. What is that cryptic stuff? Why don't you just say, repeat 4 times, print 1? And of course, you lose a little bit of power, right? Because at the top level, you cannot do 1, 2, 3, 4. You can only do 1, 1, 1, 1. But that's fine because they're learning. When you're learning a natural language and you don't have periods unlocked yet, you can only do sentences on one line, but that's okay because you're learning. You don't need the full power of the whole language if you're starting. So yeah, this leveled language, that is Hedy. That's the gradual approach to programming that we have made that follows exactly these steps and even has a few steps before reaching this step. So then now, of course, you don't want to look at me talking, you want to look at programming, right? This is Code Week. So let's do some demo, actually. Let's look at Hedy just to check. Do you see my browser now instead of my slides? Yes, I see a thumbs up. Okay, so this is Hedy. Notice that this is live on the internet, hedycode.com. So if you don't want to listen to me and you just want to go to that website and play with Hedy yourself, I don't blame you. This is all online, so you can also try this out yourself. What you see here is the first level of Hedy. You see, it is a very simple language with just a few options. For example, I can try this, print, welcome to Hedy. And I can just run the code, and here the code is executed. So notice, no brackets, no quotation marks. I can simply write the word print, and whatever follows print, whatever that is, good evening, Code Week. It doesn't matter what it is, it will just be print. At this first level, children can just get used to the mechanics of programming. The idea that this is where you type and then this is where the output occurs. The idea that there's a button to run code. These things, if you're a novice programmer, are already mind-blowing. You don't know where to click. You don't know this idea of typing and getting input. What we also have at the first level, because what's important in Hedy is that, yes, it is simple, but it should also be so powerful that you can build stuff that's sort of cool and interesting, that gets you hooked, that you will want to learn more. So what you can also do is ask something. So instead of printing, we now just have the word ask. And if you say, ask what is your favorite color, and you run the code, you get interaction. So now Hedy is asking me, what is your favorite color? So I can say green. Nothing happens yet, but we have that accounted for as well, because we have a keyword that's Hedy specific called echo. And echo repeats input to the user in a sentence. So it can make the program a little bit more exciting. I could say, ask what is your favorite color? And then I will echo, so your favorite color is ... and that's where the answer will be printed. So what is your favorite color? Green. So your favorite color is green. So you can make a little bit of interaction, and you can use this, for example, to have a small interactive story. Like, who is this story about? And then I can say echo, this story, is about. So we have, where she lives. So we have echo that's going to print with the answer at the end of the sentence. And then we have print as well. So if I run this, who is this story about? Feline. In the Netherlands, Feline is where she lives. So you get this weird sentence, maybe a little bit of Yoda speak to make sure that the sentences match the end. But you can create an interactive story. And we're actually later in the presentation going to look at some examples of Hedy programs that children created already at this first level. So the important thing is that it is easy. It mimics some of the important parts of programming, printing, input, and it allows you at every level of Hedy to create something that is fun and interesting, that you're like, oh, this is cool. Now I would want to do more. Because this level 1, of course, also has some limitations, like the fact that you can only print the input back at the end of the sentence. So that's level 1. Let's go to level 2. This is level 2. In level 2, we introduce variables. So in level 2, you can use a variable. And notice that variables also are simpler than we're used to. So I can just say name is Hedy, and then I can print welcome name. If I run this code, then it says welcome Hedy. Notice if you are someone with a little bit more experience in programming, we do some secret magic here behind the screens, because this thing is a string. This is printed exactly as is. But this thing is a variable. This is replaced by Hedy in the code. Children don't have to worry about that at this stage. They will have to worry about it later, but they don't have to worry about it at this stage. And notice that now that we explained that here as well, we don't really need echo anymore, because now we can print using a variable. For example, we can say color is, we store the result of an ask into a variable, and then we can print color is your favorite. Oops, that's not what I meant. I wanted to run this code so you can see green is your favorite. And similarly, I can have a story like the story that I had before. I can say, what is your name? And then I can say, oh, why not color? Color can be a name. Lives in the Netherlands. So now I can make sentences where they answer the one that I have asked with asked is at every stage in the sentence. So very much like in natural language, having a period unlocks the power of longer sentences. Having a variable unlocks the power of making sentences with input at every location. Maybe you've also realized that we have some sort of a problem now as well, because there are things I cannot do. Suppose this variable is called name. If I ask, what is your name? And I store the answer in the variable name, and I would want to print, so your name is name, this is a problem, because this name is not that name. This name is a string, and this name is a variable. So if I run this code and I say Ramon, why not? It doesn't have to be Feline all the time. Then we get, oh, so your Ramon is Ramon. This is an issue. So I like this problem actually, because this problem is a learning opportunity for children. Because now when I go to the next level, I can go to level 3. In level 3, we unlock the quotation marks. And the nice thing is that if you use this, now I can say, just like I had before, name is ask, what is your name? Now I can say, hello, name. So now I can fix my problem. Oh, your name is name. If I run this code, Pauline, your name is Pauline. So now I have taken children with me in my story of syntax, right? Firstly, I've shown them, look how annoying a world is where you cannot make the difference between a variable and a string literal. That would mean that if I use name as a variable, I can never print the word name anymore. That's not what you want. Therefore, we need quotation marks. And I really like that, actually. My first idea behind Hedy was very much to create a language that was easier and would gradually like up the cognitive load of children. But once I built this and once I started to see how children are using it, I think that it also has very much value as a way of explaining why syntax is there. If you taught textual programming languages to children, I'm sure you have been in this situation where kids ask, hey teacher, why does a closing bracket go there? Why does a quotation mark go there? And then you have to say, yeah, just because this is just the way the language is designed, which is sort of a weak answer. I don't like giving that answer, but at that stage, of course, you're not gonna explain parsers and compilers to a 9-year-old to explain why brackets should go there. I don't propose explaining parsers and compilers to a 9-year-old. However, secretly I am, because they have now also been in the journey of a language designer. They do see that, oh, but if I don't have quotations, I get this and this issues. So that's also something I really, really like about Hedy. At this point, Hedy is available. We have 8 levels, and Hedy is available, let me show that to you, in English and Dutch and Spanish and French and Brazilian Portuguese. So in many different languages, you can try Hedy, and then everything is translated. So just let me show you how Spanish would look like. The programming parts stay the same, but everything else, all the examples and the whole user interface switches to Spanish or English or Dutch. So that was the demo. Then let me share with you a little bit about how it's going, because of course I can imagine you're curious. So Feline, you built this super cool thing. How is it? Well, not bad, actually. Thank you for asking. My tiny project that we launched in March it's going quite well. So far over the last 6 months, 70,000 Hedy programs have been created by random children on the internet. So that's, that's pretty cool, if I may say so. In all the programs that we've seen so far, 17% of programs contained an error. So maybe you're like, wow, 17%. That's like 1 in 5. That's not great. Well, actually, regular programming languages are known to have error rates around 50% for novice programmers. So something like Java, 50% of Java programs that new programmers create have errors. So that's not so great. So 17% actually is a pretty good number for, 17% is actually a pretty good number for programming languages aimed at novices. We are quite happy with 17%. Of course, we want it to go down, but we're quite happy. Of course, as I said, you don't want to listen too much. You want to look at programming. So for the rest of the talk, we're just going to look at Hedy programs that children have created. And I want to point out to you certain things that I think are really interesting and are underlining the strengths of Hedy. So let's look at some programs. I thought let's look at the good programs, the bad programs, and the ugly programs, because this is not only a marketing talk for Hedy. So I also want to show you where there's still friction and where we can definitely improve. Maybe this is a good moment also for a small break, because maybe you were wondering, why is this language called Hedy? Well, actually, Hedy is named after the inventor Hedy Lamarr. This is Hedy Lamarr, and she was an actress, but also an inventor. And the reason that I named my programming language after Hedy, well, firstly, like, look at her. She's amazing. Who is an actress and also an inventor? Isn't that just cool? But the thing she invented is something you probably love as much as I do, because she's one of the creators of Wi-Fi. So the algorithm that Hedy Lamarr designed that makes radio communications hop to different frequency is something that's used in modern Wi-Fi networks. So that's something that, it enables everything in live Wi-Fi internet. So that's pretty cool. And also this hopping of different frequencies somehow reminded me of my language hopping through different levels. So Hedy is named after Hedy Lamarr. Now, after that small break with some interesting facts, let's look at some Hedy programs. First, the good programs. So here's a program. It is in Dutch, but it was a cool program to point out. So what you see here is that children can create pretty long programs, and that they're also using language elements as we designed them. So this is a level 1 program in which the first sentence says, ask who is the main character. And then the program is a mix of echo, which we just saw repeats what a person put in, and prints that just print something. So the result of this program, if you actually run it, then this will be the result. So at ask, you enter the name, and this will be the name, the program. So at the Montessori school is John. At a certain day, he's sitting in a class, John. So here you see, you need this Yoda language to make the sentence make a little bit sense. No one is sitting next to him. He's thinking, where is Pete? When the bell rings for the break, John is searching on the square. So you see, children are using this print and echo to create an interactive story. And the interesting thing, like when I was looking at this program, is that they are using variables, but they don't really know they're using variables yet. Clearly, this John in the storyline is a variable. It has a name, and it's used in multiple different places. So they can explore the idea of variables and understand why it has value, because then you can have your own name within an interactive story, but they don't have to think about all of the stuff that comes with it. So they don't have to think about what is the name, what is the type of the variable, how do I do string concatenation, none of that, but they can still see the power of variables at work. So that's level 1 program. And also, of course, I picked out this program because it's really cool to see that children build something substantial in Hedy. Here's one that I just really liked, a level 2 program, because this is the type of fun that I also had when I was a 10-year-old. This program says, what is your name? And then it asks, would you like a stinking explosion? Yes, here it comes. Bam. Do you want a poem? Here's the poem. Flip, flop, floop, you're a crazy chicken. It just makes me ridiculously happy that children come up with this stuff. This is, as I said, this is like exactly the type of fun that I like to have when I was 10. And also it shows you like the power of programming, right? Programming something creative, and you can play little tricks on your parents, like, hey, do you want a stinging explosion? Yes, bim bam, you're a crazy chicken. It's just very cool. This is a program that I also really like. This is a level 4 program. And what you see here, that children are using Hedy to mimic real software in real life. Because what this program is doing is it's asking for a password. So it asks for a password, and if the password is Pepino30, then it prints welcome, and otherwise it prints wrong. And then, and this is what I liked about the program, then it prints many empty lines, and then it prints hello. So it sort of mimics logging in, and then the login screen being removed, and then you entering the real application. So what I liked here is that it's really the beginning of creating software. This is a small programmer that's using Hedy, that is trying to use Hedy in a way that you can make real software. So that's what I really liked about this program. So that were some good programs, right? I was browsing through the programs today. It's like, oh, this makes me happy. This is so cool. But I will also show you some errors. So this is a category of bad programs where not everything is going well. And these programs also represent common errors that we still see in Hedy. So what we see here is someone saying, Prince, the main character of this story is Lucas. Lucas is going to walk in the forest. So this program creates an error because the second line doesn't have a command at level 1. It should be either print or ask or echo. So this is a program that creates an error, and then you do get an error message. You see here, by the way, that error messages are also localized. So this error message is in Dutch. It says, sorry, we couldn't really read your code well. Lucas, which is the first word in the sentence, isn't a command in Hedy 1. Maybe you meant ask. So I guess in this case, they didn't mean ask. I think what they meant is, again, print, but at least we're trying to be helpful. So if you are programming in Spanish or in French, then your error messages will also be shown in Spanish or French, which is a little bit more child friendly than always seeing your error messages in English, as a language like Python or Java would typically default to. This error, as I said, is actually a common error. Forgetting keywords at this point is the #1 error that we're seeing in Hedy, where children write a line, maybe they get so excited about programming that they forget certain keywords. This is the cause of about 20% of all the errors. So, as I said, about 20% of the programs have an error. From that 20%, about 20% again is caused by children forgetting a keyword. And this is an error. This is why it's bad and not ugly. It's sort of okay. This is actually the most common error in other programming languages also. So in Java, they're also omitting something, forgetting something like a bracket or a semicolon is also the most common type of error. So this is maybe just inherently hard in programming or in life in general to get something very precise and complete. Here's another one. Level 2. Program print. This is going to be a fun game. Work is ask, what is your job? Echo, work. So the problem here is a little bit different. Again, we say, sorry, we couldn't read your code very well. Echo is not a command in Hedy level 2. So echo is a command, as you've seen, in level 1, but it's not a command at level 2. In level 2, you don't need echo anymore because you have the variable work. So what the child meant to do here was print work rather than echo work. So this is actually the #2 error that we're seeing, where children accidentally use level 2 code at level 3 or level 3 code at level 1. It goes both ways, actually. This is also the cause of about 20% error. So there's a little bit more. I think it was like 18.8% for omitting something and 18.6% for mixing levels. So it was very, very close together. And this is a Hedy specific issue. Because we have the levels, the price that we pay is that 1 in 5 programs containing an error has children confused about the levels. So this is definitely something that we want to work on in the future, where we know that echo doesn't exist at level 2 anymore. So maybe we can do something smarter than just say, oh, this is wrong, we don't know this command. Because the level is so small, maybe we can guess more or less, use some artificial intelligence to guess what the child might have meant. We can try maybe 10 or 20 variants of the program, run all of them and see if there's one that matches, and then maybe try to ask the kid, is this what you wanted? So this is an issue that we're aware of. And of course, we expected that this gradual level might have children confused about different levels, and that's something that we work on. So then I also have ugly. This was just bad. Like, this was a mistake in a program, and here's an error. You know, it can happen. But we are also sometimes really ugly. So I'm opening up here a little bit. Bear with me. If you type this code at level 7 is where we introduce indentation. So we have a repeat in line 1, and then in line 2, the child has forgotten to indent the code, and then line 3 is indented. So what we should say here is something like, hey, you forgot to indent something, but what we actually say is, unexpected token anon 10 print at line 2, column 1, expected one of *_EOL. So like, this is not great, right? This is why it's in ugly. I understand that if children see this, they're like, never mind, we're giving up. Actually, one of my students now is analyzing exactly what is the program that children create before they leave the website. So I'm sure that this is a contestant. I think it's likely that if you see this, you're like, this is unreasonable. What can I do? Whereas actually, yeah, the error mentally for us is very easy to see. And this is just where creating a programming language is, I know it's a lousy excuse, but creating a programming language is hard. And the reason that Python or Java do not have this gradual approach is because it's really, really hard to get this right. So sadly, here we get some unpleasant error messages. I have another one for you. So here is another question. This is at level 7 again. Answer is asked, what is the color of your house? If the answer is green, print good. And then you see else is still correct. And then line 5, again, indentation is forgotten. And if I look at this from the eyes of a teacher, I'm like, this is so understandable because they have the if and then they indent. And then the else is back, back to the normal beginning. So they're at this normal beginning and then they're like, oh, and now I just have to print. It makes so much sense that a beginning programmer would do this. And then this is what we throw at them. Expected token anon underscore 10 print at line 5, column 1, and expected star underscore EOL. So again, not great. This is really something that we want to improve, but getting this right is really, really hard. So there's a big discrepancy between what a teacher or a grown-up with programming experience can see that the child meant to do and how easy it is to get this into a computer. So again, this is really what we're focusing on to make this better. And probably the best guess that we have actually is, as I said, making small modifications to programs. Because the program is so small and the language is so small, we can just try to turn a number of knobs, like, oh, add an indentation here, add some spaces there, and see if this is the right way, and then check with the child if that's what they wanted to do. So improving error messages is definitely one of our important focuses. It is not going to be possible to fix all programs and to always give meaningful error messages, but at least we want to give children the impression that programming is doable and learnable, and that Hedy is here to help and not to shout at them in understandable ways. The end. That's everything I wanted to share. I have a small recap, and I also see with an eye on the clock that there's still a little bit of time for questions, so that's great. If you want to know more about my work, I'm on Twitter. My handle is my first name, super easy, @Feline. If you want to know more about Hedy, you can go to my website. That's the easiest way for information, feline.com/Hedy. Maybe you had realized this or wondered about this, but we are actually open source. So all the source code of Hedy is on a website called GitHub, where everyone can contribute. So if you want to have new features, if you want to have an extra button, if you want to make any suggestion, go to feline.com/Hedy so you can navigate to our code. A way that you can support the work that we're doing, even if you don't know any programming, is you can help us with translations. As I said, we are available in Dutch, French, Spanish, and Portuguese, but there are many other languages out there in EU. For example, German is a language that we don't have yet, or Italian. We have really clear instructions on our website about what you should translate and how. If you hand in those translations to us, then Hedy could also be available in your favorite natural language. So that's a way that we would really love your help, even if you're not a programmer. If you're just a teacher and you're excited to try this out with your pupils, then getting it translated in your own language is going to be a huge help to us as well. If you like listening to me, then maybe you also want to check out my podcast, which is called SE Radio. We're on iTunes and Spotify, where we interview famous, influential programmers. Every 2 weeks, we have another episode. So that's something that you might want to also check out. And I'll start the Q&A session with one question that I always get. People always ask me, Feline, have you drawn those slides by hand? Yes, I have. Actually, by hand is somewhat modern. I use an iPad and I draw with a pen on my iPad in an app called GoodNotes. So it's sort of half electronics and half handmade. And with that, I would love to hear anyone with questions.
It seems, Feline, everyone is a little bit hesitated to ask questions.
There
is one. There is one.
Oh, one. Cool.
Yes. Which age group which age group of students have you tried Hedy with?
Yeah, that's a great question. So we think Hedy is doable from around the age of 10, because you do need a little bit of computer fluency. You need to be able to click and type, and you also need to be able to read a little bit of natural language. Of course, we do always get emails from parents. We have had emails now as well. Oh, I have a 7-year-old and I really loved using it. But I've also seen emails from someone that said, well, I tried it with a 12-year-old and it was actually quite challenging and I didn't know how to do everything straight away. So there is definitely an age range for which it works. And I think it also highly depends on the context in which you use it. So if you are a teacher and you have a little bit of programming experience and you see an error like, unexpected EOL, you might know what to do. Whereas if a kid would do it alone, or if a kid would do it with a parent that isn't so tech or programming savvy, then you just get stuck. So it is like a multi-dimensional thing, somewhat depending on the age and the level of the child, but also depending a little bit on the guidance that we have. For Dutch, just for Dutch at this point, we also have instruction videos in which I explain how everything works in a video and I demonstrate how it works. That's also the reason that many of the programs that I showed you were in Dutch, because we've been seeing lots and lots of usage in the Netherlands, because then kids can do it reasonably independent because they can watch me do it on a video and then copy it, which is of course going to be a little bit easier than reading the instructions. For English and Spanish, we do have written instructions, but teaching children, listening to a 3-minute video is going to be way easier for them than reading a 2-page document with instructions. So in Dutch, it's probably also doable with slightly younger kids because they can follow along in the videos. And of course, we do want to make the videos for other languages as well.
It seems that the questions are drying up a little bit.
Yeah, no more questions. Yeah.
No more questions. I'm very inspired by your presentation. It's always fun to see this happening. How often did you give this presentation? Is this something you do weekly?
Oh, so this presentation, I designed the final half just for this talk. So the first half, like with the background, I've done a bunch of times, and also the stuff where I compare cognitive load for different fields, that I've done maybe 5 times because there haven't been so many conferences because of COVID. And then all the programs with the good and the bad and the ugly, I actually designed that today, especially for that talk. So that was a bit new.
Well, I do think we can add a little bit to the 70,000 programs that have been made. I think we can ask everyone to add at least 1 program today. It's very easy to start, and it's not very difficult to master. I really enjoy using it in my classroom. I'm using it in our first and our second grade in secondary education. The students are between 12 and 14, and it's always fun using it. They go like, "Oh, is this Feline? We know Feline from Scratch in the Classroom." So there's a very high interaction between the material and learning new things. Yes, I do not see any questions in the chat. Perhaps Paulina,
I see more questions. Yes. There is a strong focus on using visualizations like in block-based programming environment with middle school students. What are your views on using block-based versus text-based programming languages for students to introduce them to programming?
Yeah, I think that's an excellent question. Maybe it should go in my presentation somewhere, because this is a question that I get often about Hedy. Like, I love block-based languages. Like Ramon said, I made a lesson series about Scratch for kids in Dutch. Scratch is amazing. But the sad thing about Scratch, and maybe you've also experienced this with middle schoolers, is that around the age of 12, 13, they start to see Scratch as being something for kids, as being something for maybe their younger siblings. In the Netherlands, especially, we have a cutoff between school types at 12. So we have elementary school until 12 and high school above 12. So that's also in our country where children feel themselves age, right? So if they're at high school, they don't want to do stuff for elementary school anymore. And this is a pity, because I think didactically, there's a lot more that these children could learn from Scratch. Often they haven't seen the ceiling of Scratch in terms of concepts. They haven't seen make your own blocks. They haven't really explored events and signals. So they could learn more in Scratch. However, they don't want to, because Scratch is for kids. They want to do a real programming language, and they see Python or JavaScript. They see languages that are made with letters, with text, as being realer languages. They realize also, of course, because it's true, that there aren't professional Scratch programmers. That isn't going to get you into being a professional programmer, whereas Python is, for example, what Instagram is built on, Python to a certain extent, and YouTube. So stuff that they know and like is built with languages that aren't Scratch. That is actually one of my motivations to build Hedy, is that these 10, 11, 12-year-olds, they come to me and say, teacher, 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 we're done with Scratch, we want to do Python. But then if you go from Scratch to Python, it's just, as I said, unreasonably hard. In Scratch, it's just clickety, clickety, click. Whoa, you have a super cool program, cool animation or a cool game. And then in Python, you have to do print, open brackets, quotation mark, hello world, quotation mark, close. And then what do you get? 2 words on the screen. So it's a lot of work for a little payoff. And I don't know the solution to that. I don't know if maybe somehow Scratch should be made to look more serious. I know, of course, there's Snap that looks a little bit more serious, but still children get from us adults that it isn't real programming, that they somehow want to have something that's textual. So that's definitely the gap that Hedy tries to fill, that children really want to do Python, but they cannot because it's made for adults, for professionals, and not for learners. And then it's sad to see children drop out, that they either go back to Scratch and they don't really like it, or they think, oh, Python is too hard, and they give up on programming entirely. So that's the sweet spot that Hedy tries to hit.
There is one more question, and I also have one, but there was one more question. What language is Hedy programmed? Is it also programmed in Python? That's from Esther Green. Yeah. Esther Green. Yeah.
It's hey, I know Esther. Hi, she's one of my students. Hedy is made in a combination of Python and JavaScript. So the translation of Hedy into Python, that's actually how it works. So we translate Hedy to Python with Python, and then the Python is executed, but the website is made with JavaScript.
Okay. Yeah. And I had a question when you were talking about block coding and scripting just before. In microbit, you can very easily change between Python and JavaScript. So there is much more overlap in between the two things. And sometimes you make something in JavaScript when you do your microbit program, or sometimes you do it in block. So maybe that can be a solution also for Scratch. Yeah. If they do something like that. Yeah.
Yeah, I think that's a great solution. I wonder, so I would love to run a study on how much of the text children actually pick up. Because if you want to learn French, then you're also not going to write lots of Dutch and put it into Google Translate and then use the translated French. So maybe in between there should also be something like a teaching, practicing element of mapping everything. I don't know how much they pick up, but it's definitely this switching is definitely a good way to be exposed already to textual.
Exposed and see how it's working. Yeah.
And also it strengthens the point, like you see those blocks, they are real programming. There is real programming underneath.
Under there. Yes.
They're just helping you. So yes, I think the direction for Scratch, if their goal would be to keep children in longer age-wise, could be to more take off the furnace of the blocks and show the code underneath. But clearly this also leads to errors, because in microbit the flip over, you can of course make mistakes, and then it doesn't go back to blocks nicely. So it also opens an avenue of issues.
Yeah. Yeah.